Hello students, welcome to the video. Now we are going to study about singular matrix and non-singular matrix. Suppose there is a matrix A which is A equals to 2 by 2 matrix 1, 2, minus 1 and 3. Then the determinant of A, which is denoted as determinant A like this, it is equal to 1 into 3 minus 2 into minus 1. It is calculated like this. If determinant A is not equal to 0, then such a matrix A will be called as non-singular matrix. It is a non-singular matrix if its determinant is not 0. So a matrix having a non-zero determinant is called as a non-singular matrix. If it is singular, then its determinant will be 0. Let us consider a 3 by 3 matrix. Say for example matrix B, which is equal to 1, minus 1, 0, 0, 1, 1, 1, minus 1, 1. If you calculate its determinant by its property, then we can easily see that the determinant of B is equal to 1, which is not 0. Again, we have another example of a matrix B whose determinant is non-zero. Then such a matrix whose corresponding determinant is not 0 will be called as a non-singular matrix. And also one more thing, if there is a non-singular matrix, then only we can say that its inverse exists. Now what do you mean by inverse of a matrix? Hence we go up to the definition of an invertible matrix. Let us consider, let A be a square matrix of order n. Suppose A is a square matrix of order n, that means its order is n by n. Since it is a square matrix, so one index n is enough to denote for rows and columns. So it has n rows and n columns. Instead of saying n by n or n square, it is better, it is customary to call its order as n. So A be a square matrix of order n. If there exists another matrix, B of the same order, such that A and B, both the matrices satisfy this equation. A dot B is equal to B dot A equals to IN, which is nothing but the identity matrix of the same order n. Then we can say that if A and B both satisfy this equation, then we can say that A and B both are invertible matrices, or we can say that A is an invertible matrix with B as its inverse. So we can say that the matrix B is called as the inverse of matrix A, and in this process A and B will be called as the inverses of each other. So we can write A inverse equals to B and B inverse equals to A. So for this definition, we can also say that if A and B are non-singular matrices. What are singular and non-singular matrices? We have got this definition just now. We discussed that if those matrices whose corresponding determinant is non-zero will be called as non-singular matrices. So this definition is helpful in defining the inverse of a matrix. If A is invertible matrix, then A has to be non-singular. So its determinant has to be non-zero. So if we can consider like this, if A and B, we can define it like this: A and B are non-singular matrices such that A dot B is equal to B dot A equals to I, which is the identity matrix. Then we call A and B as invertible matrices, or we can also say that A is the inverse of B and B is the inverse of A. Hence A and B are inverses of each other. So in the next definition, we are going to study how to calculate the inverse of a matrix, inverse of a non-singular matrix of 2 by 2 order or 3 by 3 order by elementary row operations or elementary column operations. So it's very important to know for every student how to compute the inverse of a matrix. There are different ways, but we are going to study in the next video how to compute the inverse of a matrix using elementary row operations. Thank you.